Hello class, we continue our previous lecture. So today we continue combined bending and torsion. Now when a shaft is transmitting torque and due to torque they is subjected to shear stress. Now at the same time shaft is also subjected to bending moment due to its self weight. So due to bending moment the stress is developed on the shaft which is bending stresses. So both both shear stress and bending stress on the shaft. So we consider a point. At the point there is a bending moment and the torque at this section, and here is, let D is the diameter of the shaft, T is torque at the section, and M is the bending moment at the section. Now torque T will produce a shear stress and the bending moment will produce a bending stresses. Now from the torsional equation we know the shear stress at the point Q, and the distance of the point from the center is R is equals to torque produced by the shaft divided by polar modulus of inertia. So for maximum, that is maximum shear stress it produced at the outer surface, so tau is equals to torque produced by the shaft into radius divided by polar moment of inertia. Now put the values of J and R in terms of diameter, so it will give tau is equals to 16 T by pi d cube. Now for bending equation, which is equals to m by I equals to sigma by y equals to E by R, so we use m by I equals to sigma by y. Now both the from both the terms, for maximum bending stress at outer surface, that means y equals to dy 2, so sigma b equals to 32 m by pi d cube. Now we know that the angle theta, that means now here shear stress and the normal stress are act on the element. So here we take the principal stresses and principal stresses in that section. So we know that angle theta made by the plane of maximum shear with normal cross section. So tan 2 theta is equals to 2 tau by sigma, that is failure plane. Suppose here is, so here is, suppose okay. Now tan 2 theta equals to 2 tau by sigma. So here 2 tau by sigma, and is the maximum tau for the circular shaft, and sigma b is for bending. So here tau is 16 t by pi d cube and sigma is 32 m by pi d cube. Now we solve it, it will give t by n. Now tan 2 theta is equals to t by m. The failure surface, the failure plane is acted t by m, and 2 theta equals to t by m. Now for the measure principal stress, now for here stress, shear stress and the bending stress acting on it. So here is only unidirectional, and shear is acting on it. So here is sigma by 2, there is a formula sigma 1 plus sigma 2 by 2, but here only sigma is there is no sigma 2, so sigma by 2 plus root of sigma by 2 whole square plus tau square. Now sigma is sigma b and tau is for shear stress is produced due to torque. So we put the values of sigma b and tau. Now pi 16 by pi d cube is there, and remaining portion is n plus root of n square plus t square. Okay, here is the maximum principal stress. Similarly for minor principal stress, here is the plus is replaced by the minus. So here is minor principal stress. Now for the maximum shear stress, we subtract from this major principal stress minus minor principal stress divided by 2. It will give the maximum shear stress. So here it will give 16 pi d cube root of n square plus d square. Now for the hollow shaft, we put d equals to d outer minus d out. Here the polar modulus of inertia or moment of inertia is d outer to the power 4 minus d inner to the power 4 by d outer. So we put here for the major principal stress and minor principal stress and maximum shear stress. This is the expression for hollow shaft. Now the time for problems. Now here is the question. The maximum allowable shear stress in a hollow shaft of external diameter equal to twice the internal diameter. Here is one condition. The outer equals to 2 times of the inner. So is now the shear stress, maximum allowable shear stress is 18 Newton per mm square. Determine the diameter of the shaft if it is subjected to a torque of, here is the torque value and the bending moment value. Now here is the condition of combined stresses. So here maximum stress, here is the given data. Torque will produce this much and moment will produce this much. Now let d outer equals to external diameter and d equals to internal diameter, and the given from the question d outer equals to 2 times d inner. For maximum shear stress, we see here is the formula for the maximum shear stress. Okay, we use this equation. Now we put the values of d outer, this is which is equals to 2 times of d inner. So put the values here, and n and t values we put it here. So root of 4 square plus 3 square is the 5, 5 into 10 to the power 6. Here and calculate the values, it will give d inner, that means internal diameter, which is equals to 34.88 mm. Now d outer is equals to 2 times of d inner. We put the values of the inner. So interior part, interior diameter. So it will give to 69.7676 mm. Will end. I hope you understand the topic.